Okay, so now we're going to see how to identify horizontal asymptotes. Horizontal asymptotes are if I have a function and if you have a graph, if you have a graph that stabilizes or kind of becoming horizontal at some height, then that height, that y value is the horizontal asymptote. So the y value stabilizes to that height. And then if such a height exists, then a horizontal asymptote exists. So we're going to find horizontal asymptote by finding, let's find limit x goes to infinity of 3x squared by x squared plus 4. So if you have this function and as x becomes x goes to infinity, what happens to the height of the graph? So we're going to do the numerical method, and so maybe we can graph it first. We could just graph this function. Right, so you can see that this graph that it stabilizes at some height. So if we kind of zoom in, so we can see that the graph is stabilizing at some height here, and this is the height we are trying to find. All right, so we're going to do this numerically. So I'm going to kind of let's create a table, and we're going to choose x values. And for the y value, we're going to input the function f of x. This is the y value, y equal to. This is the y value. Okay, so I've entered the function 3x squared over x squared plus 4. So we're going to make x go towards infinity. So x goes towards infinity, which means x is very, very large. So as x approaches infinity, what happens to y value? Okay, so that is the limit. And so we're going to choose x very, very large, maybe starting with the 100 and 1000 and 10,000 and then one more number. So we can see that it is already rounded to 3. So this whole thing, so the y value goes towards 3. So the y value approaches 3. So let's find the horizontal asymptote as x goes to negative infinity. So as x approaches negative infinity, which means on the left side, what happens? What happens to y? So we're going to choose negative numbers here, the same large numbers but negative values. So I can see that even on the negative side, as x, I've chosen values negative 100, negative 1000, negative 10,000, and negative 100,000. So x is approaching negative infinity, but the y value is approaching 3. So y value approaching 3. So if the limit, if there exists a finite limit, then there is a horizontal asymptote. Horizontal asymptote is going to be the line y equal to 3. So this question is about identifying vertical asymptotes. Vertical asymptotes are what look like this in the graph. It is an imaginary line, and so if you have a line here, there is an imaginary line, and the graph shoots up towards that line, and the graph shoots down towards that line. So there is an imaginary line, and the graph shooting up or down towards that line is a vertical asymptote. So vertical asymptote exists when denominator could be 0. So the x values when denominator is 0 are suspects for vertical asymptotes. So we're going to start off with the denominator equal to 0, and you put x minus 2 equal to 0 and get x equal to 2. And now, is there a vertical asymptote? Is there a vertical asymptote at x equal to 2? Of course, we can answer that by identifying limits. So we want to argue limits. The left limit at 2, so which means x approaches 2 from the left side, what happens to f of x? And as x approaches 2 from the right side, what happened to f of x? So basically the y value, we're talking of the y value here. This also is the y. And as x approaches 2 from the left or from the right, what happens to the y value? Does it shoot up or down? We're going to use, we could use a plug-in technique here. If you plug in 2, the whole thing will become undefined. So if you plug in 2, it will become 3 times 2 by 2 minus 2, which is undefined. And so plug-in method will not work here. So we're going to resort to numerical method. So let's create a table. So it's going to be x, and okay, so we have 3x over x minus 2, and so this is, note that x approaches 2 from the left side. X approaches 2 from the left side. So let's try to draw a number line. So 2 and x approaches 2 from the left side. So we're going to start off maybe with 1.9 and then move closer to 2. So I'm going to and then one even closer to 2 will be 1.99, 1.999. So we can see that the numbers are still negative but becoming larger and larger with a negative sign. So this whole thing goes to, so as x approaches 2 from the left side, it becomes a very large negative number, but the process can continue. So this whole thing goes to negative infinity. So negative infinity is the left limit, and the right limit would be x approaches 2 from the right side. So we're going to start off with 2.1 and then move closer. So start with 2.1 and 2.01, 2.001. So we can see that identify a pattern here. So it's becoming a very large number, and the number is growing. The y value is growing as x approaches 2. So this whole thing will become positive infinity. So because at 2, on one side it is going to, so the graph itself will look like this. If you have 2 here, on the left side of 2, the graph shoots down, it goes to negative infinity, and the right side, it goes to positive infinity. So this is the vertical asymptote situation. So vertical asymptote at x equal to 2.